Good morning, class. Today, we're taking a look at additional applications to what we looked at in section 6.3, talking about formulas. We are going to need to be able to translate word problems into actual workable math problems. And that's what we're looking at here. Linear equations are equations that would, if graphed, form a line. So there's not going to be a lot of exponents and those types of things. It's going to basically be solving for a variable. So let's take a look at it. When we look at these problems, we need to translate words into math. So when you see things like add, you might see the word sum or total or together or more than or increased by or and or deposit. For subtraction, we'll see terms like minus, difference, take away, remove, less than, decreased by, withdraw. Multiplication brings things like times, product, half, that's times 1/2, double times 2, twice is also times 2, triple times 3, and per. And then divide, you're going to see the word divide, quotient, share, per, distributed among, and share. I don't know why it's on there twice, but it's on there twice. Additionally, you might see things like is, and is normally means equal sign. We're going to see a couple examples of that before we get into the homework. Here we go. First things first, we need to take these words, turn them into a mathematical expression. We also call these models. 6 more than a number is x plus 6. We can use any kind of variable we choose to. In this example, we're using x. Another one, 4 times a number. This is going to be a number, whatever letter we want to use. Let's say x again, and it's 4 times that, so 4x. The next example here, 4 less than 3 times a number. 4 less than 3 times a number. So we're doing minus 4 of some kind. That's where 4 less comes in. And then 3 times a number is going to be 3x. 3x minus 4. Fourth example here, 5 more than the quotient of a number and 8. Quotient is where we're doing division. A number and 8 means we're going to have x over 8, but then we're going to add 5 to that to get the 5 more than. So we're basically converting these word phrases into mathematical expressions. A couple more examples here. Equations. When you see the word is again, is equivalent more or less to equal to. So 6 more than a number is 10. 6 more than a number. So we're going to use the letter x again for number. X plus 6 equals 10. Twice a number decreased by 6 is 12. Twice a number decreased by 6 is 12. Twice a number is 2x. Decreased by 6 is going to be minus 6, and that's going to be equal to 12. A number decreased by 14 is 6 times the number. Ooh, we have the word number in here twice. Guess what? We're using variables on both sides of the equal sign. A number decreased by 14, so x minus 14 is equals x times 6, or 6 times the number. So that's how we'd write this. X minus 14 equals 6x. In the text are a couple examples. I'm going to go through a few of those as I've got them in this slideshow here. But it would be valuable to you to go back and take a look at them in case you get lost. First one is Henry's Truck Rental Agency. Happy Henry's Truck Rental Agency charges $250 per week plus 21 cents per mile for you to rent a small truck. How far can you travel to the nearest mile on a maximum budget of $500? I'm not going to worry about the cost of gas at this point. Well, to set this up, we need to come up with an equation. First things first, rental fee, which is $250, plus the mileage charge, which is 21 cents, equals the total amount spent. And we have a couple of these numbers. We have the rental fee, $250. We have the mileage charge times M. We don't know how many miles we're going to go. That's what we're trying to solve. Has to be equal to, or in this case, less than $500. So we subtract 500 from both sides. Again, we're trying to solve for M. We get 0.21 M equals 250. We then divide both sides by 0.21. And we get M is about 1,190.48 miles. So you can go about 1,190 miles. If you go more than that, you're going to pay extra money. So 1,190, that's to the nearest mile. And with any of these, you really should be doing a check. And so when you do a check, you can take that number, M equals 1,190, and put it back in the problem. So I would take 1,190 times 0.21 plus 250, and I need to get a number that's less than 500. That number is going to be 499.90. So we would be under that $500 mark. Example number 2, Rob wants to fence a rectangular region of his backyard for his Chihuahua. He only has 56 feet of fencing to use for the perimeter of the region. What should the dimensions be if he wants the length to be 4 feet greater than the width? So we're taking a look at length times width, or length plus width, I should say, because we're looking at perimeter. We've got the perimeter is equal to twice the length plus twice the width. And as we solve this out, we've got a total of 56 feet of fencing. We can simplify this down to 2 times the length, which we want to be 4 more than the width. That's where this x plus 4 comes in, plus 2x. As we solve out for x, we can get 56 equals 2x plus 8 plus 2x. 56 equals 4x plus 8. And then we solve it by subtracting 8 from both sides, getting 48 equals 4x divided by 4. X is equal to 12. So the width, which is what the x we were solving for is, can be 12, and the length can be 16. And we'll use up that amount of fence. Third example, Ryan is planning to open a hot dog stand in New York City. Good luck, Ryan. What should be the price of a hot dog before tax if the total cost of the hot dog, including the 7% sales tax, wow, is to be $2.50? This is like when you go to the concession stand and you say, okay, I'd like a cheeseburger, and they say that'll be $5. Well, that $5 theoretically should include the 5.5 in Wisconsin, 5.5% sales tax. So in New York, it's a 7%. So he's trying to get it down to a nice round number so that he can charge the appropriate amount. So what do we got here? We got price plus the sales tax is going to be total cost. Total cost is $2.50. Sales tax is 0.007. Price, that's what we're trying to solve for. We don't know what that is. So we know that we need to take whatever the price is plus 0.07 times that price. We want to get 250. To solve this, we add 1x plus 0.007 to get 1.07x, 250. Divide both sides by 1.07, and we get $2.33, which will pretty much round up to $2.34 per hot dog. So this is just a few examples. Again, I would recommend you read through, especially on page 282. It has step-by-step how to solve a word problem in case you forgot. Just like last lesson, this lesson will involve some writing. You need to be able to show your work. So read 281 to 284. Homework for 281, 284 is 284 to 286 is 4 through 26 even. Most of those is reading the words, the phrase, and turning it into a mathematical expression. So that's why 4 through 26 are pretty straightforward. And then when you get into the word problems, I just picked a couple that might be interesting, especially as high school students. Feel free to read a few of the other ones and be like, oh, that'd be kind of neat to know. So you can take a look at some different methods or different problems you might come across in your lives. But all of these are going to require you to write out a fair amount of work. So please do take the time to do that. That's it for today. If you have any questions, please ask me or email me. I will see you in class.